Okay, greetings everybody, to the live viewers and the people who watch later. Thank you for tuning in. This is Joseph Postma, and I'm giving a talk today on that there is no radiative greenhouse effect. We will establish that for a fact today. So let's get to it. So here's an overview quickly. We'll cover the derivation of the radiative greenhouse effect, where it comes from, how it's derived. Then we'll get right into what the faults are of the derivation, what's wrong with it, paradoxes that are actually embedded in the derivation. We'll look at violations of thermodynamics, which come out of the derivation. We'll look at empirical contradictions to predictions. And then we'll discuss logical reality. What is the real greenhouse effect? What actually determines the nature of the atmospheric temperature distribution? And we'll discuss a few other things as well. So right to it. This is the derivation of the radiative greenhouse effect. If you do a Google search, you'll find these sort of diagrams and this sort of derivation everywhere, exclusively. This is how it's derived. This is where it comes from. If you don't find diagrams like this, then you find text which describes diagrams like this. So this is where it comes from. Here's 6 examples. 5 different universities, plus an example from thermophysics, well, a textbook named Thermophysics, which I have from my undergraduate degree. So it is the consensus and the only derivation of where the radiative greenhouse effect comes from. So there's one basic fundamental problem with this derivation. Do you see it? Now, I've went to rallies recently, well, a rally recently, protesting the Alberta carbon tax, which has been put in. And I brought this diagram and I showed it to people. I said, do you see anything wrong with this? And they would scratch their head and they would say, oh, well, you know, it's been a long time since I did any science. I'd have to sit down and look at these numbers. I'm not sure. I'd have to take a look at these numbers and see if they're correct. I'm not sure. It's much simpler than all that. Yes, there are numbers there, and the numbers give the appearance of science, give the appearance of being physics. The problem is right in front of your face, and nobody sees it. Do you see it? What's the problem? The Earth is flat. Yes, that is a problem. It is a problem that the Earth is flat in this diagram. I don't know why people don't think that it's a problem. Well, we will establish exactly why it's a problem and what happens when you do this. But first, let's just say this for fun. It has been a truism of logic for thousands of years. Maybe somebody could find a quote. Maybe it's in something Aristotle wrote, or maybe in the Republic somewhere, or someplace like that. But if you start an argument with incorrect assumptions, then your conclusions which follow from whatever you derive, whatever you extrapolate, whatever you conclude from that argument will likewise be false. They carry along the original error. If you start with something erroneous that doesn't exist, you end with something erroneous that doesn't exist. This is how logic works. It's basic reasoning, and it's also science. Maybe it helps to see it in an equation, right? True equals true, false equals false. 0 is not equal to 1. False is not equal to true. Earth is not equal to flat. Right? It's important. It propagates. The error propagates, and it propagates in meaningful, substantial ways. And we'll see what those ways are just ahead. We have this diagram here. Now, if you think that this is some sort of simplified model or something like that, the numbers in this diagram don't care if that's what you're thinking. These are numbers here, and these numbers are saying that this is what exists. This diagram is saying that this is what exists. Well, it is not what exists, because the Earth is not flat. So this is not an average model either. This is not an average system. The Earth is not on average flat. The average of the Earth is spherical. There's no basis in reality, either in averages or an approximation or anything in which this diagram has any bearing on reality. It has no bearing on reality. And it is from these diagrams from which the radiative greenhouse effect is derived. So what difference does it make? So given the false premises, what errors are subsequently being made? One error is that Earth's effective temperature is being used as the solar input. This is being done by conserving energy. It conserves energy by equating fluxes over equal areas instead of total energy over unequal input and output areas. Right? Energy is not conserved by equating fluxes, but by equating total energy. The solar input to the Earth does not occur over the same surface area as Earth's radiative output. The incoming flux and the outgoing flux are different. They are not equal. By equating fluxes, you dilute the solar input over the entire surface area of the Earth. That does not exist. That is not reality. Solar input does not exist over the entire surface of the Earth. It occurs only over half of the surface of the Earth, and that is the system average. So this model dilutes solar input, this derivation dilutes solar input over the entire surface area, thus getting rid of day and night. Well, that doesn't exist. Diluting the temperature forcing potential of sunshine down to minus 18 degrees Celsius on a black body. Therefore, this derivation says that sunshine is unable to melt ice, and it says that sunshine isn't responsible for summer, that the greenhouse effect is in fact responsible for melting ice and for creating summer and higher temperatures above minus 18 degrees Celsius. Now, the real absorbed solar constant is actually really hot. It's 121 degrees Celsius. Raw, if you take off 30% absorption for albedo, then it's 88 degrees Celsius at the zenith. So real solar input, solar flux, is actually a very high temperature. You can feel that when you stand outside. These diagrams say something which does not exist. Now, there's actually a paradox embedded here. If the Earth were flat, as shown in the diagram, this diagram says the Earth is flat, and the absorbed solar flux was 240 watts per meter squared after taking off 30% for albedo, then the Earth would need to be 2 times distant than it actually is. This diagram says that there is a flat surface facing the sun which receives 240 watts per meter squared after taking off 30% for reflectivity. In order to achieve that, this surface needs to be at 2 astronomical units, distance from the sun, because the real solar flux constant after taking off albedo is 960 watts per meter squared. To get that down to 240, it needs to be reduced by a factor of 4, which means moving the distance of this surface by a factor of 2 in order to get the inverse squared law reduction of a quarter down to 240 watts per meter squared. So to have a flat surface facing the sun receiving 240 watts per meter squared, this flat surface would need to be 2 times distant than the Earth actually is. So there is a paradox embedded in this derivation. Now, why would that be? Well, like goes to like, error goes to error. Once you start with an error, you're going to find errors everywhere. Errors everywhere, and we will find that there are so many errors, starting from that one basic error of having a flat Earth. It propagates out to everything. So the derivation of the radiative greenhouse effect is founded on a paradox. There's a paradox inside it as to what the distance of the Earth is. Now, it doesn't matter if you claim that this is a simplified model. These numbers in this diagram function as if this is what literally exists. They don't know that you're thinking of this as something else. These numbers are saying what they say. And in saying what they say, they have a paradox embedded in them, aside from the Earth being flat, which it isn't. So let's look at a thermodynamic fault. Radiation from the atmosphere must have to add with a solar flux to make this surface warmer than the minus 18 degrees Celsius from the solar flux. So you have two temperatures. You have two sources that are minus 18 degrees Celsius, and they add together to make higher temperature. Now, what do you think of that? Let's add two ice cubes together. Do they make a higher temperature? No. Let's add 2 cups of hot tea together. Do they make a higher temperature? No. That's fake thermodynamics. Further, the Stefan-Boltzmann law is being used incorrectly here. This part here, well, related to this temperature thing, basically what they're doing is adding 2 temperatures together and saying that this is going to create a new temperature. That's not the Stefan-Boltzmann law. That's an erroneous application. The SB law is that for a given surface temperature, you get a surface flux. It doesn't say that you can add 2 temperatures together to get a higher temperature. That's not the Stefan-Boltzmann law. The Stefan-Boltzmann law is this: F equals sigma t to the 4th. Or if you know the surface flux, then you can get the surface temperature, which is creating it. The SB law does not say that you add 2 objects together to get a higher temperature. This Stefan-Boltzmann law does not say that radiation from a cold object can warm up an equal temperature or warmer object. The Stefan-Boltzmann law is not heat, it's flux. It's not heat. We'll get to that in a second. So temperatures and fluxes, they never add in thermodynamics. You never get that. You never add 2 temperatures together to get a higher temperature. That's fake thermodynamics. It's not real. Everyone knows that. The only thing that temperatures or fluxes do in thermodynamics is subtract, in which case you get heat. Now this is going to be a long slide and I'm going to narrate it all, but I have to because it seems that people have a very poor understanding of heat. So these are all quotes from textbooks, 4 or 5 different textbooks I had on hand. Heat is defined as any spontaneous flow of energy from one object to another caused by a difference in temperature between the objects. We say that heat flows from a warm radiator into a cold room, from hot water into a cold ice cube, and from the sun to the cool earth. The mechanism may be different in each case, but in each of these processes, the energy transferred is called heat. That's from thermal physics. This is also from thermal physics in a different section. If a physical process increases the total entropy of the universe, that process cannot happen in reverse, since this would violate the second law of thermodynamics. Processes that create new entropy are therefore said to be irreversible. Perhaps the most important type of thermodynamic process is the flow of heat from a hot object to a cold one. We saw that this process occurs because the total multiplicity of the combined system increases. Hence the total entropy increases also, and heat flow is always irreversible. Most of the processes we observe in life involve large entropy increases and are therefore highly irreversible. Sunlight warming the earth, for example, and it goes the same as to say Earth's surface heating the atmosphere. That process cannot happen in reverse. It's irreversible. This is from a textbook called Thermodynamics. Heat is defined as a form of energy that is transferred across a boundary by virtue of a temperature difference or temperature gradient. Implied in this definition is the very important fact that a body doesn't contain heat, but that heat is identified as heat only as it crosses the boundary. Thus, heat is a transient phenomenon. If we consider the hot block of copper as a system and the cold water in the beaker as another system, we recognize that originally neither system contains any heat. They do contain energy, of course. When the copper is placed in the hot water, when the copper is placed in the cool water, and the two are in thermal communication, heat is transferred from the copper to the water until equilibrium of temperature is established. At that point, we no longer have heat transfer, since there is no temperature difference. Neither of the systems contain any heat at the conclusion of the process. It follows that heat is identified at the boundaries of the system, for heat is defined as energy being transferred across the system boundary. And of course, that transfer is from hot to cold. Now, this is from classical and statistical thermodynamics. The temperature of a body alone is what determines whether heat will be transferred from it to another body with which it is in contact, or vice versa. A large block of ice at 0 degrees Celsius has far more internal energy than a small cup of hot water. Yet when the water is poured on the ice, some of the ice melts and the water becomes cooler, which signifies that energy has passed from water to the ice. When the temperature of a body increases, it is customary to say that heat has been added to it. When the temperature decreases, it is customary to say that heat has been removed from it. When no work is done, the change in internal energy equals Q, which is heat, which says that the internal energy change of the body is equal to the heat transferred to it from the surroundings. One definition of heat is energy transferred across the boundary of a system as a result of a temperature difference only. This is from Elementary Applied Partial Differential Equations, which is actually all about the study of heat flow, since that's where and how Joseph Fourier developed the Fourier transform. And that's what applied partial differential equations eventually I'll get into. So how and why does heat energy flow? In other words, we need an expression for the dependence of the flow of heat energy on the temperature field. First, we summarize certain qualitative properties of heat flow with which we are all familiar. 1. If the temperature is constant in a region, no heat energy flows. 2. If there are temperature differences, the heat energy flows from the hotter region to the colder region. Alright, so this establishes that the cooler atmosphere cannot send any heat to the surface. Heat is a very well-defined concept in thermodynamics now, and it goes to say that if you violate the definition and law of heat flow, then you're violating the laws of thermodynamics in general, as these laws are at least partly, if not significantly and totally, founded upon what heat is and what it can do. Radiant flux from the cooler atmosphere cannot transfer as heat to the warmer surface. Now, Schrader in thermal physics says much of thermodynamics deals with 3 closely related concepts: temperature, energy, and heat. Much of students' difficulty with thermodynamics comes from confusing these 3 concepts together. Well, indeed, this is of course me speaking now, the fact that any object will spontaneously emit thermal radiant energy is being confused with what heat is, and when energy may or may not behave as heat. That is, just because the atmosphere or any object may emit thermal radiant energy, it does not mean that that energy can act as heat for another object. There is a requirement that for that energy to act as heat, it must come from a warmer object. There are 2 ways to increase an object's temperature in thermodynamics. One is heat and the other is work. Those are the 2 ways to increase a body's temperature: heat and work. Radiant flux from the atmosphere serves neither of those causes. For the warmer surface, it cannot act as heat, and it performs no work. There is no mechanism by which radiation from a cooler atmosphere can lead a warmer surface to become warmer still. There is no mechanism in thermodynamics by which radiation from the cooler atmosphere can cause a warmer surface to become warmer. The radiation from the atmosphere does not send heat, and it does not do work on the warmer surface. So, of course, logic still wins. Don't worry, we're going to get into a lot more theory and some empiricism too, just to further make the point. Aside from what was already discussed with cold sunshine and the flat earth, the radiative greenhouse effect claims responsibility for the temperature gradient in the atmosphere. The diagrams and the derivations show that radiation from the atmosphere is what causes the surface to be warmer than the atmosphere, and hence the existence of the lapse rate. That's what these diagrams show. They claim responsibility for the lapse rate. That means the way that the atmospheric temperature decreases with height above the surface. These diagrams say that the radiative greenhouse effect is what causes that. However, the lapse rate actually exists and has a cause independent of the greenhouse effect. This is the simplest derivation here, the simplest way to derive it. However, if you look on Wikipedia, there's another way that meteorology does it, but it's basically the same equations. Reduces the exact same terms in the end, minus G over Cp. And the concept is the same. It's an adiabatic lapse rate. This is calculated without any reference to radiation whatsoever. You could remove carbon dioxide completely from the atmosphere and it would barely change this Cp value, this thermal capacity, because carbon dioxide is such a negligible contribution to the net thermal capacity of the atmosphere. And then, of course, the surface gravity is constant. So this lapse rate, the lapse rate comes from a totally independent calculation from the radiative greenhouse effect. It's completely independent of radiation, completely 100%. Now then, if you factor in latent heat release from rising moist air parcels, then you get the wet lapse rate, which is smaller at minus 6.5 Kelvin per kilometer. If the radiative greenhouse effect should induce its own additional lapse rate, which it says it has to, according to the diagram, it says that this is a physical effect of the radiative greenhouse effect. It induces a lapse rate. Then you should find larger lapse rate than what is calculated without reference to radiation. And we do not. The measured dry lapse rate is minus 10 Kelvin kilometers, 10 Kelvin per kilometer, and the measured wet lapse rate is minus 6.5 Kelvin per kilometer. So aside from the theoretical errors, this single empirical data point totally refutes the radiative greenhouse effect. It totally refutes it, full stop. I mean, aside from the theory errors and the derivation errors and the flat earth and all that. Sure, let's go along with that. And what's the empirical prediction? Well, the empirical prediction is that it should induce a lapse rate. Well, does it? No, it does not. The lapse rate that exists in the atmosphere is solely that due to the strength of gravity and the thermal capacity given by this equation or the derivation from meteorology. And there's no radiative contribution whatsoever. So it's done. It's done. Theory has totally refuted the radiative greenhouse effect, and even if we go with what it says, its empirical prediction or claim is totally refuted as well. Now, interestingly, when the strongest greenhouse gas, water vapor, is present, the lapse rate actually decreases. It doesn't increase, leading to cooler surface temperatures, not warmer. So that's an interesting contradiction to what actually occurs. So the radiative greenhouse effect has neither theoretical nor empirical support. And the word chimera popped in my mind, and I looked it up. Oh yeah, it kind of fits. Mythological fire-breathing monster. Well, that's apropos. Grotesque monster having disparate parts. Yes, it is grotesque. You look at that diagram in terms of trying to represent reality. No, it's a grotesque distortion of reality. Flat Earth, fake thermodynamics, cold sunshine. Yeah, all that is grotesque physically from a scientific perspective. A horrible or unreal creature of the imagination. Sure, why not? Its most basic claim of creating a temperature gradient is empirically refuted, and there is no mechanism in thermodynamics by which thermal radiation from the cooler atmosphere could cause a warmer surface to become warmer. The radiation does not heat. It does not do work. It does not lower the surface emissivity. We'll get into that in a second. It does not stop the surface itself from emitting, and heat is not a conserved quantity. So we'll get into that last sentence a little bit more up here. So just as an aside, here would be something that looks more like reality. This is just a diagram schematic I came up with to try and represent the radiative interaction between the sun and the earth a little more realistically. So now we have a top of atmosphere solar flux, which is actually really high in temperature. Around the zenith, it's almost 88 degrees Celsius. Well, now that makes sense, right? Because we all know that sunshine is really warm. And it's hot, in fact, if you're under the equator. But more than that, there's this diagram called the radiative imbalance or energy imbalance diagram, the latitudinal energy imbalance. Oh, excuse me. But it shows that around the equator, more sunlight comes in than energy that is emitted by the Earth, whereas around the poles, the Earth emits more energy than sunlight that comes in. Of course, these two areas balance each other out. Now, the radiative greenhouse effect diagram with its flat Earth can't explain that. In fact, this empirical measurement is totally in contradiction to that radiative greenhouse effect derivation. That radiative greenhouse effect derivation, how could it ever lead to this sort of an imbalance? It couldn't. This diagram, however, directly leads to an imbalance like this, because the temperatures under the equator generally aren't 88 degrees at the surface. So where's the energy actually going? The energy goes into latent heat, because latent heat, and that's in water, in liquid water and water vapor. Latent heat, or the phase of latent heat, allows thermal energy to be absorbed without an increase in temperature. So thermal energy is being absorbed here, but it's not increasing the temperature. That energy then transports through the atmosphere and through the oceans to the poles, and then cools and comes out of the latent heat phase there when the water vapor condenses into rain and ice and snow and whatnot, and at the poles when the water freezes and loses the latent heat of liquid. And I just came up with this on my own because I thought, let's try and make something that looks a little bit more realistic. So if you zoom into the atmosphere, then you have the natural lapse rate caused by the adiabatic gradient. And you're going to have a warmer surface and a cooler top, and the average is going to be in the middle. Now, the important point about this is that no matter what average value you expect, let's say that you have some average that you're expecting from some previous calculation, you expect some average to exist in the atmosphere, some average temperature, some average state. But you also know that the temperature has a sequential linear distribution of values. Well, where are you going to find the average of a sequential distribution? Look at the distribution 1, 2, 3, 4, 5. Where's the average of that distribution? Is it at either end? Can the average be found at either extremity? Can the average of 1, 2, 3, 4, 5 be 1? Can it be 5? Of course not. The average has to be found in the middle. Any sequential distribution that already exists, if you expect it to have some average state, then the average state is going to be found in the middle. So the existence of the lapse rate completely negates in the basic mathematics that the average of a sequential distribution has to be found around its middle. This completely negates even the need to derive a radiative greenhouse effect in the first place. It completely negates the need to derive it. You expect the average to be found around the middle. Therefore, you expect one end of that average, or one end of that distribution, to be higher in value and the other end to be lower than the average, because it's a sequential distribution. Hence, the near surface average has to be warmer than the average, and the top has to be cooler. This in itself completely negates the need to even derive a radiative greenhouse effect in the first place, let alone that it's derived from flat Earth woo-woo physics, basically. So how come I'm able to come up with a diagram like that, with diagrams like that, but they're not? I mean, do I know more? I don't think I know more. I just think that I have a proper education in physics. And we'll see that it's questionable whether or not the people promoting this stuff actually have a good education in physics. So let's look at a quote by Gavin Schmidt. And I think he was a NASA climatologist, or still is. I mean, this is a pretty high up guy, one of the highest. He says, since adiabatic means without input of energy, it seems a little unlikely that it is a source of atmospheric heating. Now, most people, now this is an old quote from Gavin Schmidt, really old. I think I came across this quote within the first few months of me this is like 8 years ago, looking into the climate issue to see which side was right and which side was wrong, or what the deal with it was, because I didn't know at the time. I came across this quote from Gavin, and I thought immediately, wow, there is a major problem here on the alarmist side. There's a big problem if people are saying things like this. Now, who can read that statement and tell what's wrong with it? Does anyone know what's wrong with that statement? Any undergraduate in physics should be able to tell what's wrong with that statement. Let's see. Adiabatic means temperature change without heat input, because temperature can also change via work. That's what the adiabatic gradient is about. It is about a temperature distribution in the atmosphere which occurs because of work being done on the atmosphere. But Gavin says that that's impossible, because it means without input of energy. Now, you say that to most people who are laymen, they're not gonna know what to say in response to that. It looks like science, it sounds like science. Well, it's actually not scientific at all. I think this was when I came up with the idea of sophistry, which eventually became my website, Climate of Sophistry. But this is a sophistical statement. It's scientific sophistry. That's precisely what adiabatic means. Adiabatic means temperature change without heat input. But Gavin says, well, that means that it can't exist. So now we'll go on. So this is an alarmist. You expect them to say things like this now at this point. Now we'll go to a skeptic. And this is Robert Brown. He's a skeptic from Duke University. And yes, all kudos to the skeptics for doing the work that they do. But the point is that you're not doing enough work. Well, I'll get into that in a minute. So this is a Duke University physicist. He says, radiant heat flow is Q equals F surface minus F atmosphere. And since Q is the heat from the sun, given by sigma T sun to the fourth, and is constant, then if F atmo increases, F surface must increase also in order to keep Q constant. Now again, most laymen will hear that, and how could they argue against that? That sounds totally scientific. I mean, they're the terms, that's what they say. It sounds like science, it looks like science. Well, in fact, it's totally not scientific at all. Q there in this equation is the heat between the Earth's surface and atmosphere. That's how heat is defined. It's defined as the flow of heat energy between two objects. The first object is Earth's surface, the second object is Earth's atmosphere. This Q is the heat flow between them. It's not the heat from the sun. He's saying something about this equation which is totally 100% false and meaningless. Q also is not a conserved quantity that must be kept at some constant value. Q is not a conserved quantity. You don't conserve heat. Q goes to zero in thermal equilibrium. Q tends to zero. Naturally, Q goes to zero. That's where it wants to go in thermal equilibrium. And sigma T sun to the fourth is not heat. That's the Stefan-Boltzmann law for flux, and flux is not heat. Heat is the difference between fluxes. This term itself is not heat. Now Q from the sun, the heat flow from the sun, is actually zero. It's actually zero. The heat flow from the sun is actually zero. And I'll have a caveat for that in a second, given that the sun and the earth are in thermal equilibrium to first order approximation. Now, of course, aside from short-term and local diurnal variations where sunlight does indeed transfer as heat, in the morning sunlight transfers as heat onto the surface and warms the surface up. Yes, that does happen, of course, so sunlight does transfer as heat. But on average, if you look at the system in aggregate total, Q from the sun, you would say, is zero, given that the sun is not known to be changing Earth's global temperature. And but with its sunlight, I mean, the temperature might be changing because of magnetic effects, cosmic ray effects that are due to Earth or the sun's magnetic field. But in terms of the sun's radiation, it's not known that the sun's radiation is causing any sort of long-term or current change in Earth's global temperature. So basically, there's a heat balance of thermal equilibrium, which means that Q is 0 from the sun on the largest scale. You know, aside from the morning, the sun obviously does heat up the surface. So the heat from the sun, yeah, and finally the temperature of the sun is not a function of the difference between Earth's atmosphere and surface temperatures. Look, that's what he's trying to say, that the temperature of the sun is a function of the difference between Earth's surface and atmospheric temperatures. I mean, that just makes no sense. I mean, why would the temperature of the sun be a function of the difference the difference between a planet's atmospheric and surface temperatures? It's just physically meaningless. The entire statement is physically meaningless. Physically meaningless. And here's Roy Spencer. He's a skeptic climatologist. Now, this statement is more clever, and it's a much better statement. It's a much more rational statement than the one above, or than the two above. However, it is still incorrect. So Roy typically says things like this: everything else considered equal, a colder object can make a warmer object warmer still by blocking heat flow from the warmer object. If heat flow is blocked, then the warmer object must become warmer to compensate. That is how a thermal blanket works. That's the atmospheric radiative greenhouse effect. So a bunch of things here. Heat is not a conserved quantity and actually goes to zero in thermal equilibrium. The colder object would rise in temperature to equilibrium without the warmer one increasing in temperature. The warmer one cannot rise in temperature if there is to be equilibrium, and we know that things do tend to equilibrium. If warmer objects became warmer still because and as they warmed the cooler object, then thermal equilibrium would be impossible, because as the cooler object warms, this induces the warmer object to become warmer. But now the warmer object is warmer, which means it has to warm the cooler object some more. But now the cooler object has become warmer, which requires that the warmer object become warmer. You see, it's a runaway process. It's not a process that would lead to equilibrium. It completely violates thermodynamics. And the fact that things tend to equilibrium, for things to tend to equilibrium, it means that the cooler things have to come up to the temperature of the warmer things, and that the warmer things do not increase in temperature because the cold one increased. So heat flow also cannot be blocked. It's spontaneous. Heat flow is spontaneous, just like emission given by the Stefan-Boltzmann law from a surface is spontaneous. If Q becomes smaller, this doesn't mean that the warmer object is emitting any less energy. It just means that equilibrium is being approached. It doesn't mean that it's not emitting any less energy, because it's still emitting according to the Stefan-Boltzmann law. That emission is spontaneous. All right, so how do thermal blankets work? They work because, one, they trap air, which has been heated by the body inside the blanket, thus making the occupant's sensory perimeter feel warmer. Convection has been prevented. The occupant heated the air inside. The air inside did not heat the occupant. And two, they have low emissivity, because they're typically these space blankets or thermal blankets. They have a shiny gold or silver surface that's highly reflective, and that means low emissivity. And low emissivity reduces external radiant emission, and that does lead to an increase in temperature to achieve the same emission. That's true. However, that is not the radiative greenhouse effect. Lowering emissivity is not the radiative greenhouse effect. Now, as an aside on that emissivity point, if greenhouse gases were said to lower the atmospheric emissivity, then there would never have been any slayers, and everybody would say, well, of course, if you reduce something's emissivity, then its temperature must increase in order to emit the same amount of energy that is required to increase. Likewise, if you increase emissivity, its temperature will decrease until it's emitting the required amount of energy. So look at the total inversion of greenhouse gas logic here. Greenhouse gases aren't said to reduce emissivity. They actually are said to be emitters. The whole supposed problem with greenhouse gases is that they emit. Well, that means that they have high emissivity, whereas the major constituents of the atmosphere, nitrogen and oxygen, they don't emit. So if greenhouse gases are said to emit, that means that they are increasing the emissivity of the atmosphere. If they're increasing the emissivity of the atmosphere, that means that the atmosphere would have to cool. So you see that the logic of greenhouse gases and the radiative greenhouse effect is totally inverted to physics. And it all stems from this initial problem of being based on a flat Earth. Now, it doesn't matter if you say that, oh, well, the mechanism is still valid, and then you go put that mechanism in a more complex 3D real-time model. All you're doing is wrecking a more complex 3D model that could have been correct. You're just putting something wrong into it now. It doesn't make the mechanism correct if you put it into something more complex. The point of the logic was that you're deriving it from something illogical, and so the mechanism you derive from it is illogical. Yeah, so this point of greenhouse gas emissivity, it totally refutes the whole concept behind the radiative greenhouse effect. Again, if greenhouse gases lowered the emissivity of the atmosphere, then you would say that the atmosphere would have to increase temperature. However, it's in fact the exact opposite that they say. Greenhouse gases are said to increase the emission from the atmosphere, but in physics, that would lead to a lowering of the atmospheric temperature, not an increase. So it's just totally inverted. And as I said, you start from one air and the air propagates everywhere. The air is everywhere. Like, look at these attempts to save the greenhouse effect. It's just running into air. It's like every time you try and save it, you try and save something that doesn't exist, you're going to come up with erroneous interpretations of things to try and save it. The point is that it doesn't exist. Now, all kudos to the skeptics for doing what they do, for trying to bring rationalism into climate alarm. But the point is, you're not being skeptical enough. You're not being rational enough. Because if you give the alarmists an inch, that's all that they need. If there's any effect whatsoever due to the greenhouse effect and carbon dioxide and all that, they'll take it. And that's all they need. It doesn't matter if you reduce it to less, if you reduce the impact to less than 2 degrees Celsius or less than 1 or whatever. That's all that they need. And they'll keep going with it. So why not, on the skeptic side, on the rational side, go all the way and say, actually, your entire premise of alarmism is completely non-existent and you have no case whatsoever. It's not that you have a little bit of a case and not so worrisome. It's not that you have a big case or a small case. It is that you have no case whatsoever. None. So these are some of the most cleverly pseudoscientific, erroneous things that physicists can say in their attempt to save something which doesn't exist. Now, this is real pseudoscience. I mean, when somebody says that the Earth is 4,000 years old or created 6,000 years ago, or whatever, I mean, do you call that pseudoscience, or do you just call that, crazy or random meaning on the statements? I mean, if you want to look at pseudoscience, this is really clever pseudoscience, because this looks just like science. It looks and reads just like science, while not actually being scientific at all. It's really clever. That's how easy it is to lie to people. All right, look at that flat Earth diagram that I described showing to people, and they'd say, oh, well, I'd have to look at the numbers. And they completely miss what's right in front of their face. That's how easy it is to lie to people with science. Just say things that look scientific, have some numbers written down, while not being scientific at all. It's amazing. So let's look at a confusion of the greenhouse effect term. So in thermal physics, he says this mechanism, and he's referring to the radiative greenhouse effect, is called the radiative greenhouse effect, even though most greenhouses depend primarily on a different mechanism, namely limiting convective cooling. Okay, so my point is then, why call it something that it is not? Because now everyone thinks that a greenhouse and the radiative greenhouse effect are the same thing, and they're not. And he says it right here that they're not. Well, then why name them the same thing? Why call them the same thing? That just introduces confusion. And who's that serving? Doesn't serve truth. Confusion doesn't serve truth, I'll tell you that. The Newspeak mechanism of a greenhouse effect is the postulated radiative phenomenon, and hence has been labeled as a radiative greenhouse effect. And the other mechanism is a physical phenomenon involving the physical entrapment of gas, which thus may be called a physical greenhouse effect. The two mechanisms operate on physically distinct principles, and therefore they should be named separately as such. The physical greenhouse effect operating in actual greenhouses functions by preventing convective replacement of warmed air. In the open atmosphere, air warmed in contact with the sunlight-heated surface will naturally convect because air that has been warmed, warm air, has lower density. It rises, convects upwards, and is replaced then by cooler air falling from above. This limits the near-surface air temperature at the bottom of the atmosphere to a lower value than if fixed air parcels were heated in place in contact with the surface. That is, the warmed surface air is constantly being replaced with cool air. So by trapping a fixed parcel of air at the surface within an enclosure, a real greenhouse allows the air inside to be warmed to a higher temperature because that air cannot convect away to be replaced by cooler air. And recall that the solar constant isn't minus 18 degrees Celsius, but it's actually really high. So you're allowing that air to be warmed to the full potential of the sunlight coming in, which is quite warm. Also, the glass of a real greenhouse has lower emissivity than the ground surface, and because the glass top of the greenhouse is now the new surface, and this new surface has lower emissivity, then that also will lead to a higher temperature. And so this is how your bed blanket works, trapping air, stopping convection, and that's how a thermal blanket works. And this is not a radiative greenhouse effect, but a physical greenhouse effect. So this type of language manipulation, confusion, it's sophistry, and it's pseudoscience, or it's newspeak. I mean, it's certainly not helpful. The physical greenhouse effect does something thermodynamically rational, which you can explain with basic thermodynamics and basic theory without violating anything. The radiative greenhouse effect, as we've seen, fits neither thermodynamic theory nor the empirical results it predicts, and when people try to come up with alternative explanations to defend it, as we have seen, they likewise run into error. So here we are, summary 1 of 3. So I start to branch out a little bit here. Climate alarm and even basic climate science is based in pseudoscience. That is, in physical paradoxes. It's based in a physical paradox. As climate alarm is based on the radiative greenhouse effect, and even most of climate science is based on this idea of the radiative greenhouse effect. And this greenhouse effect, this radiative greenhouse effect, is based on a derivation which has a physical paradox embedded in it, and violations of thermodynamics. I don't know why this doesn't matter to people. It matters to me. Some people go far out of their way to avoid it, even the skeptics, and I don't know why. Now, if you want to talk about a danger of CO2, a real danger to life on the planet, for example, would be CO2 depletion due to geology. Geology is constantly leaching carbon dioxide out of the atmosphere. Now, we were much closer to the point at which you get CO2 asphyxiation in photosynthesis than we were at a high level of CO2. I mean, we're really low down in our concentration of CO2, even after it having increased for a little bit. We're still really, really low. So if we didn't, and we're vilifying this chemical element, which is essential to all life. I mean, if we didn't have enough of it, and we were close to not having enough of it, really, in geological terms, we were quite close to not having enough of it anymore. That would be global extinction. I mean, global and final extinction. But for some reason, the narrative has been inverted from that. By using hydrocarbons as fuel, man is replenishing the carbon dioxide that used to be in the atmosphere but was leached out of it due to geologic history. And even if we burn them all, we'll only get to 2 times the pre-industrial level, which is actually still close to the asphyxiation level in geologic terms compared to what has existed before. Earth life evolved with up to 20 times the concentration of CO2 than we have now, and that's what it prefers, and that's why we increase the concentration of CO2 in greenhouses. It helps plant growth. You'll notice that in the sort of academic scientific culture today, and even in mainstream culture, more and more we're finding this anti-human, anti-meaning attitude towards human existence. Now let's go back to logic. Given that like goes with like, true equals true, false equals false, false not equals to true, then let this anti-meaning attitude uses pseudoscience to support itself, then the position itself must also be illogical and pseudoscientific. Well, sure. Life has not evolved over billions of years of struggle just to find itself discovering that it is bad and shouldn't exist when it gains the ability to think about itself. I mean, it's just so crazy. If you think of the dinosaurs, for example, what an amazing species they were. Everybody loves dinosaurs. If we ever have time machines, it'll be on every single person's bucket list to go see the dinosaurs. They're amazing. Like, what an amazing species, right? Or what do you call it? Kingdom, whatever that was. And it was lost by a geologic accident. You know, just like the depletion of CO2 would have been a geologic accident leading to the end of all life. You know, it was a planetary geologic accident that wiped out the dinosaurs with that giant meteor and the Deccan trap volcanoes that were triggered because of that. Wiped them out. What an amazing loss, but we exist now due to that loss. I mean, think of what we are. We landed on the moon. Think of cavemen looking at the moon. Like, you step out of that your cave and you're like, holy cow, what the heck is that thing up in there in the sky? And you run back in your cave because you're like, what the heck is that big scary light up there? That thing is insane. Do you see that? Do you see that light out there? That light is insane. And then we walked on that thing a few thousand years later. I mean, that is amazing. But it seems there's, you know, and I think that's amazing. I think that means that humans are amazing, but it seems there's this other narrative that says that humans are awful. So here's this new idea that we see from environmentalism, this idea of the carrying capacity of the earth, that we're exceeding the carrying capacity of the earth and we got to get back under the carrying capacity of the earth for humans. Well, here's a question. When did we exceed the carrying capacity of the earth for humans? Does anyone know when it happened? Did it happen in the 1950s? Is that when we exceeded the carrying capacity of the earth for humans? Maybe it happened around the year 2000. Maybe that was when it hit. Maybe it was during the Dark Ages. Here's when we exceeded the carrying capacity of the earth. Here's when. We did it before we have records. In prehistory. Because we exceeded the carrying capacity of the earth the very first time we planted a crop, or the very first time we penned some animals. Because we began to engineer our survival. That means we started creating systems that outperformed the natural ability of the earth to provide. We started outperforming the carrying capacity of the earth thousands of years ago with the first crop and with the first penned animals. That's when we exceeded. So is that where we're supposed to go back to? Now, just as far as uniqueness, now, science would find this statement horrific today, to say that man is important and precious and valuable and the most. Today, that statement is considered horrific. But just in terms of uniqueness, when you look at the uniqueness of what we can do, I think that makes it's a special, you know, maybe it's a glass half full versus glass half empty sort of thing. Landing on the moon is pretty special. That's pretty amazing, guys. So let's look at some facts. There's a fact that the biosphere requires more CO2 in the atmosphere, not less, and not the same as now or that at 100 years ago. Now, that is if you continue it. That is if you're interested in continuing Earth life for as long as possible. CO2 is obviously not pollution, but it's one of the 3 basic elements required for life. Now, imagine you're some sort of alien species and you're tasked with ensuring that Earth life will be able to continue for as long as possible. Okay, well, let's start at the very beginning. Let's start at the very foundation. What does Earth life need? It needs sunlight, it needs water, and it needs carbon dioxide. That's the ground starting point. Okay, so then you'd say, is there enough sunlight? Yeah, it looks like there's going to be enough sunlight for 1 billion years or so. Okay, that's good. Is there enough water? Yeah, it looks like, but I mean, the planet isn't losing water. It's got enough water. Okay, great. What about CO2? Oh, wait a minute. Look at the records. This place is seriously low in CO2. This place is dangerously low in CO2. That's what you would say. And you would say, we need to increase the carbon dioxide level stat if we're going to increase Earth life for as long as possible. That's what you would say. That's a fact. Under those terms, it's good that man's activity is replenishing atmospheric CO2. And of course, the environmentalists and the alarmists would find these statements horrific. Totally horrific. Isn't that funny? It is a fact that climate alarm is pseudoscience because it's based in what is basically flat earth woo-woo physics. I mean, let's call it flat earth woo-woo physics. What else do you call flat earth physics? Flat earth theory. It's woo-woo physics. It's woo-woo craziness. And it's based in paradox at the foundational level and has what I can only call low information processing. Scientists at the highest levels on both alarmist and skeptical sides defending it, as it is based on the radiative greenness effect. Stop defending the radiative greenness effect, and you'll stop supporting climate alarm. It's a fact that there's no radiative greenness effect that's established empirically and by basic thermodynamic theory. It's a fact that man always has and always will live beyond the natural carrying capacity of the Earth. I mean, think of it, for example, an environmentalist would say, what's the natural carrying capacity of outer space? Oh, well, that's 0. What's the natural carrying capacity of the moon? Oh, well, that's 0. So does that mean we shouldn't go to the moon and we shouldn't go to outer space? I mean, that's basically the future we're looking at if we lived by that philosophy. The natural carrying capacity of outer space is 0, so that means we shouldn't go there. Well, we have went there. We have exceeded the natural carrying capacity of the Earth and of outer space, and that should have been impossible if there was such a real thing as carrying capacity. It's obviously not a real limit since we've been able to break it. And how do we break it? We break it with engineering and with the use of our mind. So it's a fact also that the anti-value, relativist, anti-human ideology, which has been adopted by science, overrides science's ostensible desire for truth. And hence, science will continue to teach flat earth woo-woo physics. I mean, I've been doing this for how long? I've been trying to tell people. I mean, we're at the point that I cannot tell physicists, other physicists, that the earth isn't flat. Think of the crazy situation that is. I am unable to inform other physicists that the earth is not flat, that you cannot start with a flat earth theory and get anything that has any bearing on reality. I cannot tell other physicists that and have them agree. Isn't that crazy? I live in a crazy world. So the real threat to human existence is not having more of the source of life. I mean, look at these people. They're getting hysterical and saying that having more of the source of life is going to kill all life. I mean, that doesn't make sense. Yes, having more of the source of life is going to kill all life. No, I'm sorry. It doesn't work that way. Having more of the source of life is a good thing if you're interested in life. So what does man subsist on? What does man actually subsist on? Do we subsist on our claws and our fur and our teeth? That is not how we subsist. Do we subsist on our instincts? Barely, not really. What do we subsist on? What do we subsist on? Man subsists on his mind. And the mind only has one use, and it is the ability to discriminate truth. Well, also in the engineering and doing things like that, making animal pens and crops and whatnot. But I mean, that's all based on discriminated truth. How are you gonna plant a crop without being able to tell which is a good way to plant a crop and a bad way to plant a crop, or the concept of planting a crop in the first place, right? So what is a mind for? Mind is for determining certainties. Certainties that lead to a benefit to life, to your continued existence. So it's absolutism over relativism, fact over fiction, value over waste, utility over fraud, merit over BS. So in these terms, which are the real terms, climate alarm is an attack on the basis of human existence. Because the only thing we do with our mind and the only way we survive is by changing the environment. We became human, we became modern humans the first time we started planting crops. However, I mean, that was a long, long time ago, prehistory. Planting crops and penning animals, that's when we became modern humans. And that was the change in the environment. That was engineering the environment to outperform the natural ability of the environment to support us. Our entire existence is predicated on changing the environment. And we do that with our mind. So by saying that humans changing the environment is a bad and awful thing. It is a direct attack. It's a direct attack on the basis of human existence, not on an aspect of human existence, but on the basis of human existence. So this is becoming us versus them sort of thing. I'm not sure if anyone has noticed, but 8 years ago you could have had debates with people on this issue. It seems that in the meantime there has been a filtering or a sorting out, and I find that there is no longer any middle ground. You can no longer talk with people about this. You can either talk with people who agree with you, or you meet people who disagree with you and will not talk with you, or are simply unable or unwilling to listen to you. There has been a total filtering, a total polarization. And it's not just on this issue, it goes across the board. But there is consistency in that. I find that the people who are climate alarm skeptics are also rational about other things, such as politics and their ability to read the news and interpret the news, and the ability to tell what is fake news and what is real news and things like that. I do find that it's actually consistent across the board, which is a good thing. Well, in terms of consistency. As a logical person, you like things that are consistent. Okay. Both sides claim that the other side presents a threat to reason, science, life, the environment, children, etc. Only one side is actually right. One side is based in reason, consistency, logic, true proper science, good intention, merit, honesty, etc. The other side is based in fantasy, paradox, hysteria, emotional hysteria, deception. And it's clear now, especially after this presentation, which side is which. And unfortunately, and I don't know why this is, but I'm just going to call it as it is, climate alarm is now it's a leftist phenomenon for some reason, even though it doesn't really make sense as a leftist phenomenon, but for some reason, traditionally it probably would have been rightist, but anyway, now it's leftist. So for example, they pretend to be for the environment, but they're actually going for total political control over life. And it seems that they're actually seeking the destruction of human life, because if you're seeking to vilify the idea of human-caused change, well, then you're vilifying human existence. And, where does that lead to? And it doesn't matter if they admit it, and they never will, but we will see in a second that they do actually admit it. The outcome of the words is clear. The outcome of vilifying human-caused change is that humans can no longer cause change, but humans causing change in the environment is how we exist. So, what are you going to do with that? Look at communism, for example. They pretended to be for equality, but what was it actually? Well, it was actually about a tiny political class of people who actually had no merit other than being psychopaths and able to inveigle their ways to the top. Fundamentally meritless people who couldn't actually produce anything other than being a psychopath that gets to control other people. And they wielded total political power, and they had to murder. People talk about Hitler being bad. These people murdered hundreds of millions. That's at least an order of magnitude, at least a factor of 10 worse than what Hitler did. And they had to kill all these people in order to maintain their pretense that they were meritorious leaders. What happens when you pretend you're a meritorious leader, but you're not actually such a leader? Well, then you got to protect your position, right? If you're a psychopath like this type of a psychopath, that is. Hundreds of millions of people murdered. So we'll see, just in the next slide, you'll be shocked, and we'll see what is actually intended with environmentalism and climate alarm. So we see climate alarmists doing the same thing. They're living in opulence and luxury. They fly around all the planet, going to all these important meetings, and then they tell people, literal serfs and peasants, that they can't have air conditioning and vehicles or else the planet will boil over, this is an actual quote from, I think it was from Barack Obama. This is such a specious, ridiculous comment. It doesn't mean anything. What does it mean the planet is going to boil over? That means nothing. But of course, if you're talking to peasants and serfs, they don't know what it means, and they'll just believe you because they don't know what it means. So sometimes they do actually admit their intention. So here's an environmentalist, a nice environmentalist alarmist. My main goals would be to reduce human population, 200 million, and destroy industrial infrastructure. Well, I mean, that's a lot of killing. That makes even there was Hitler, and then there was Hitler for killing people, then there was communists for killing people. I mean, this is just like, this is order of magnitudes beyond the previous ones combined. I mean, this is a lot of killing. You really want to kill people. Human beings as a species have no more value than slugs. Oh, well, it's easy to kill slugs. The extinction of the human species may not only be inevitable, but a good thing. Yeah, great. I mean, you're human, aren't you? Do you know that you're a human? We can't let other countries have the same number of cars, industrialization we have in the US. We have to stop these third world countries right now. What happened to, wanting to help these people? How are you actually helping them by making them stay in their mud huts? I mean, that's not really helping. Or you have a strange idea of help. Isn't the only hope for the planet that the industrialized civilizations collapse? Isn't it our responsibility to bring that about? Oh, that's a nice statement. That's nice for you to say. Oh, you're a real good friend, Maurice. Nice to meet you. We've got to ride this global warming issue. Even if it's wrong, we'll be doing the right thing. Well, maybe that's why we see so much defense of the wrong greenhouse effect, radiative greenhouse effect theory. Because they got to save it, because it's what they're totally predicated on. Without the greenhouse theory, they no longer have any climate alarmism. It's totally based on the radiative greenhouse effect. So why do they put so much energy into defending it and won't allow it to be criticized or whatever? Well, that's fine. Oh, look at this lovely statement. You think Hiroshima was bad? Let me tell you, Mr. Hiroshima wasn't bad enough. That's lovely. That's a really nice thing to say. To feed a starving child is to exacerbate the world population problem. Yes, we should have more starving children. Now, these are reprehensible statements that people think are funny and which I repeat and love. I mean, I've been in, coffee meeting groups, the weekly coffee meeting group in academia, with others, with scientists and whatnot, and they say things like this. I've heard other people, regular academic scientists say things like this, and when they say them, they usually chuckle while they're saying them. They chuckle, they say, oh yeah, humans are no more valuable than slugs, we should just get rid of them, and they say things like this, and they laugh. These things are literally worse than Hitler. I mean, I know that term's getting bandied around a lot lately, of people being just like Hitler, literally Hitler, but I mean, this actually is literally worse than Hitler. Now, imagine if you're in Mordor, and you're with the goblins, and you're sitting at the goblin table at a goblin feast, and the goblins are eating their black filth and mush or whatever, and they're partying and they're talking about what they think about humans and what they want to do with the world of man. Goblins would be saying, I love starving children. I want more starving children. I love them to starve to death. That's something a goblin would say. Don't you know that's what a goblin would say? Don't you know that you were a child once, Lamont? Cool. I mean, are these people human? Maybe they're in human suits. Maybe they're goblins in human suits, and they're like, oh, I forgot I put on my human suit today. I mean, and this statement, I mean, look at this one. Human beings are just like slugs. I squash them like slugs. They're valueless. That's what a goblin would say. A goblin at the goblin feast would be saying that in Mordor. That's what a goblin would say. John Davis, did you forget that you're a human? Did you forget you put your human suit on today? Or is that just your inner goblin speaking out? Why are you a goblin? Why are there goblins here? I mean, I don't understand. I wrote this last slide and I realized there's goblins on the planet. I mean, I'm surrounded by goblins or something. This is what goblins say. This is what goblins in Mordor would say. Why do we have goblins? I don't understand it. The extinction of the humans would be such a great thing. Yep, that's a goblin. That's what a goblin would say in Mordor at the goblin feast. All right, so that's actually the last slide. So I hope you enjoyed it, and you can go to my blog and make your questions and comments there. All right, take care.